divided by R. Then you can opt for, splitting the cells into smaller bits. So at least the cluster of people that are living within this particular area would have a lot more frequency or smaller frequency spectrums, smaller frequency and base unit allocations to address their capacity needs. So at least coverages and service provision would be enhanced within this given spot. Okay. Other cell capacity increment also include, besides cell splitting and the frequency reuse of borrowing frequencies, we also do have cell sectoring or sectioning, where we have sections of the cells, in a way dividing the cells into wedge-shaped sectors, from maybe 3 to 6 sectors per cell, each with its own channel sets, with subsets cell channels to address the transmission needs. We're using directional antennas as well, so at least in those sections or those new sectioning that has been uh, 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 divided can have good reception, can provide service needs to address capacity need. And our approach is also having microcells where we move antennas. Um, we move antennas. Okay, so we have cell sectoring, and then we have microcells on an approach where we move antennas from tops of hills and then large buildings to top of smaller buildings, which is what's going on these days in most localities, especially when it comes to the newer technologies of cellular networks that are using much more smaller base units or base stations to address transmission needs for like 4G and 5G that's coming up. You're going to notice a chunk of these are going to be having a lot more of a microcell uh, implementations, and it's all a way of basically addressing increasing capacity needs. So microcells falls within that, where you move antennas from top of buildings or hills or structures to much smaller buildings and sites of buildings or large buildings itself. Even lampposts can be used as a good spot for microcells, where we place a base unit within a lamppost just to address a coverage need, so at least people don't lose signals when they are really engaged in high productivity transmission need over their handsets or whatever. And in the realm of that, within microcell, you'd have uh, formations of microcells that have been enhanced, and you have reduced power as well. Because if you minimize the cell sizes and their point of locations at higher levels to lower levels, then the power for propagating signal gets minimized. So in that sense, you actually reduce the amount of power being used by some of these base stations. Very good for city streets, along roads, and inside large buildings to provide coverage and increase capacity needs. Really good approaches that are coming. This is going to be microcells are going to be very mainstream in the coming years when 5G takes main stage within within our cellular networks. You're gonna start noticing a whole bunch of microcell, phantom cell, picocells, and what have you within various places, like within cities, along roads, along inside buildings, and it's all to basically address capacity needs for various handsets and demands of various services, either multimedia content or business processes that organizations need to, or that's businesses or even uh, subscribers needs to address their service needs or to address the transmission needs. You're going to be seeing a lot of these. There's going to be a video maybe later. I'll show you guys a video later where we showcase newer technologies within the 5G RAM and how they incorporate a number of these microcells to help stabilize and and put foot on the 5G technology that's coming up. So at least it can address the high capacity demand that's coming up within 5G networks. Okay, so we got a diagram of how cell sectioning and microcells are. Here we have a cell section of maybe of cell with radius 1.6 kilometer, within 1.6 kilometer from the 17.6 kilometers. And then you do have a micro base where you do have a limit. It's quite limited. That's from 16.8 all the way to zero point 0.8 now. Quite impressive, huh? So you do have a number of base units being installed. And like I said, the whole essence of some of these is to address capacity need. Okay, and also technological trends that are coming up. Okay. Okay, so with all that said, let's look at how operations of solar systems actually uh, uh, are done or are implemented using base centers as base stations as the center of the various cells that we have. Okay, so let's go to that and see how the operation of a solar system works. So a base station is usually the key center device of of each cell unit that you implement of most cellular networks. The base station is the key uh, system within cells, and they're usually placed in the middle of a given cell shape or pattern that we have. And the basic consists of the antenna, the controller, and then your transmitter or your receiver, which forms the transceiver. The controllers usually handles all the core processes, which is a number of mobile units that are going to be used with a given time. In that cell, it's all managed by the controller, so it's the controller's job to manage the core processes within that. And then usually base stations, your BS, they connect to mobile telecommunication solution office, which your MTSOs, um, and they serve the base station. So generally, every base station with all of its components are usually served by an MTSO or a mobile telecommunication solution office. Okay, one MTSO serves multiple base stations. So you could have a number of base stations that are being managed by one MTSO. So at least it can handle a number of issues that relates to calls between mobile units and fixed lines as well within a telecommunication network. Okay. Yeah, so obviously one MTS serves multiple base station. MTSOs links up to base stations by wires or wireless cables or whatever. If you go around, you look at some of the some of the base units that within your locality, you will notice that they go into a particular, they all link up to a particular structure, and that structure could probably serve as the MTSO where other base stations interconnect to allow for that transmission control to take place. An MTSO connects calls between mobile units and then from other mobile to fixed line telecommunication networks. They also assign voice channels as well as perform hands-off in terms of movement. So at least when you're moving from cell to cell, you don't lose your signal. And that's also termed hands-off. So they perform hands-off, and then they monitor calls for billing purposes. And more, all of these are mostly done automatically after the configurations. So engineers do configure some of these things within the devices, your routers, your switches, your ATM device, and what have you, are all configured automatically to handle some of these roles that an MTSO plays within the cell system automatically. So you don't really have to be worried about manually handling this. It's all done fully automated. Okay, fully automated, exactly. So here's an overview of a cellular system where you do have a landline connect to a PTSN, which is a public telecommunications switching network, and that actually connects into your MTSO, which is your mobile telecommunications switching office. And then you do have the MTSO managing a number of base units within given cells. So a number of cell units being managed by MTSO, and MTSO connects to your PTSN. And then PTSN usually is the public telecommunication network that handles more or less the larger uh, communication or transmission needs across various networks, various interconnected networks from various ISPs and across larger geographical areas. So for the most part, assuming you wanted to make an international call, you within a cell over here, you want to make an international call, then a call needs to be routed from your base station to your MTSO. And if your MTSO realize that the number you're trying to reach is out of it's not within its control, it's not within its MTSO control, they would hand it off to the public telecommunication switching network or your PTSN, and that will basically find the that particular number where it's at. If it's external, if it's international, if it's out of your geographical coverage, it's up to the PTSN to route those call transmission to identify where it needs to go to and pick that and then locate a particular call or service and then reroute it back to the device that is making the request. So it can establish a switch between those two handsets and have a call conversation take place. The same applies if you were driving a car, same approach. You'd be serviced by a base unit, and that's managed by an MTSO to help you with the switching of the calls between various handsets that you'd have. Over here we do have a picture of a base station with a bunch of transceivers on them. We have your antennas that form your transceivers. You do have uh, your microwaves, your radio devices, um, a number of other devices. They are most of them are just micro devices and radio devices for either uh, point-to-point connections or point-to-multi-point connections to address, service needs within a given cell coverage. So you do have this right here, and then they have cables that run all the way down to an office that's probably down here, and that office handles the switching needs of maybe either multiple cells. So that would be probably your MTSO building down here. That will be handling various transmission control needs from this base station at least, and probably other base units that it manages. So here we do have this here. What I think I had was the Vodafone cellular system on GTUC Tesla campus with base station masts. It's a mast. This type over here. It's supposed to be a T. And an MTSO switching within a switching room. When it comes to channel management within an MTSO, uh, channels are controlled from setting up and maintaining calls. Channels are controlled from setting up and maintaining the calls, and they also controlled by establishing relationship between mobile units and nearest base stations, which means at every given point in time, An MTSO is required to know uh, the location of various mobile units and their nearest base stations. So in terms of when a call comes through, it can easily identify how to route the calls easily and quickly to a given mobile units that it needs to send a message to, or that it needs to create a switching for to exchange information. There's also traffic channel controls, which is how you carry voice and data across a medium within a cellular network. So that would be your channel management approach in terms of how we establish calls and maintain it, how we identify the relation between handsets and base units, and how we manage or carry the voice and data that in general time the traffic needs for that particular channel is well sorted out within the management. Within a typical call in a singular MTSO area, you would have mobile unit initialization. So if we want to look at some of the uh, things that goes into a typical singular cell, so singular MTSO operation. How does a typical MTSO operate within a typical cell unit? How does call take place? How do you handle call transmission? How does the MTSO handle call transmission to address uh, cell channel control needs, to address uh, hand off transmissions to your public telecommunications switching networks if it can locate a given subscriber or given unit within its cell uh, management. How does it handle that? So we're going to look at a typical MTSO role in terms of call transmission. Okay. So the first thing is mobile units are initialized. That's by scanning and select stronger sets of apps of setup control channels. So you scan and select stronger setup control channels and automatically select base stations antennas of cells that are usually but not always nearest. At least you find the most well propagated antenna or base units that can handle propagation anomalies within a given base station. So even though it's a base unit or a base station antenna might not be close by, it's up to the job of the MTSO to at least keep track of how to find the strongest uh, channel or control channel to be able to manage stronger units of signaling for various devices that are within a given base station unit within a cell. Okay, and it's all done automatically. Okay, and it also handles within the mobile unit initialization. They also handle an MTSO also handles the handshakes, which is a three-way handshakes. Uh, that's required to have a circuit switch established between two devices that wants to uh, have a conversation or send information back and forth. So handshakes identify users and reach locations. It also scans for repeatedly to allow for movement. So at least when cast or within a movement, you're making a call with and you're moving along and you're moving within cells. It's up to the job of the MTSO to keep track of that, to scan across your movement and see and how far you're moving away from a given base station signaling domain, and able to identify which nearest cell can carry the signal as you get closer or further away from your initial point of uh, of a base station connectivity. Okay, so movements are all being monitored, and it's all done by MTSO, and that's pretty wild if you think about it. You can tell this the MTSO does a pretty good job. It's all These are all based on just using propagation. You propagate signals and you measure them to see how far the device is from a given base station of a given transmission uh, wave. So you can identify, whether the person is going out of coverage or not, and then when to decide to call in on another nearest base station to take over that particular call, hands off that particular call. So at least the user or that handset doesn't feel disconnected when they move from one cell to another. Mobile units are monitored for pages, so you can identify uh, key locations of mobile units at any given point in time. Uh, so mobile originated calls, they are checked out for channel. If they're free channel, then they are allocated one, and then those channels are monitored uh, through forward channelings, and then wait for idle times. When that is at, when it's when there's a free channel identified through an idle waiting period of monitoring, then uh, numbers can be sent to pre-selected channels to handle given or call has been originated. Um, Paging in the sense of how a typical call is handled within a single MTSO um, is through paging, where MTSO attempts to connect to mobile units by paging a given unit, especially if they are not within its coverage. If it's all within its management, then we page it to see if it's available, or even if it's within a given, it's up to the MTSO to make sure it keeps track of it. So at least when calls comes in, it can easily know that okay, I already have this guy within this unit or this mobile unit within my paging managing unit, so I can easily hand up the call and set up a call by creating a switch, a dedicated switch for the transmission, allocate a channel for it, so the transmission or the communication can take place. So paging messages sent to base station depend on call mobile numbers. Paging also signal transmitted on setup channels to address, signal needs. And then you also have other key things that might come into play within paging. But the key essence of paging is to make sure an MTSO knows at any given point in time where a mobile unit is. If a mobile unit were to come into a given cell that an MTSO monitors, through paging, it can identify that particular mobile unit and keep record of it. So when calls comes through and there's a request from other networks or that are not close by, can say, okay, hey, yeah, I do have this guy within my control and within one of my base unit I manage. So if you want to make a call, yeah, I can hand you off to that person easily. So that happens to be that approach. The other sides, the other ones are call accepting, where we accept the calls, where mobile units actually recognize numbers on the setup channel, response to base stations, which sends response to MTSO, and MTSOs will set up the circuit between calling and the call base station. And then MTSO will also select the available traffic channels within the cell and notify the base station. So at least that notification can go to a mobile unit for that channel request to establish that uh, call transmission, and then monitoring of ongoing calls, so you can easily for billing purposes, so you can easily identify when a call is terminated or not. So voice and data exchange through respective base station and MTSOs are the key roles that happens within a single call of an MTSO. The final one will probably be the hands off. That's when you hand off users that are moving, you know, that are moving from cell to cell, so mobile units moves out of range cells into other range of another cells. It's the job of the MTSO to keep track of that and hand them off and hand those units off to other cells. Traffic channel changes to one assigned to a new one from another base station without interruption of service to a user. So here's a typical scenario where you do have a call stage within a given cell. So you have a car over here within a car with a mobile unit moving around within this cell over here. And my guess is probably the cell unit has an MTSO that's managing this 7 base stations. Okay, so now when a call originates from this car to maybe another mobile unit that's in a different cell, it's the job of the MTSO to determine where that particular mobile unit is based on monitoring of all the base units that it manages. So you can identify the particular node or particular mobile unit that's making a call. So at least when a transmission comes through, it can easily hand out the calls. So within this setup, you have monitoring. You have monitoring for strongest signal by an MTSO. Okay. So MTSO managing this particular. Keep in mind, the MTSO could be in the middle of a cell or somewhere within the cell, not necessarily on the outskirts of it. Okay. And sometimes it can be on the outskirts. It all depends on the design layout, anyways. So anyway, within this, you'd have the MTSO monitoring all the various base units manages for strongest signal. And then when there's a call request for connection comes through, it broadcasts or pages all the various cells. So it pages all the various cells to identify where the requested mobile unit is at within its managed cells. So you can basically identify where to send the request to. And once you identify that through the paging, it can create a call, which is called the call is accepted, and then establish a circuit between the mobile unit within the cell to this particular cell where the other requesting unit is coming from. So now you do have a circuit being created between this cell and this cell to exchange transmission or conversation or calls or whatever between two handsets that are within two different cells. Okay? And then monitoring of the ongoing calls until the call is terminated or handed off. So in this case, within the hands off, the car or the mobile unit within the cell moves to a different cell. That's what you have over here. Move from this cell to this cell. It's the job of the MTSO to monitor that particular mobile unit and know when it's moving far away from the original cell or base unit to a different base unit, so it can hand off calls to this cell to take over the transmission. So the mobile unit doesn't experience call drops or transmission cutoff, and still maintain transmission within between this mobile unit at all given points until the call is ended or and the call is cut off or the transmission is cut off. Now, other functions that a typical MTSO would play is to handle call blocking during mobile initiated call stage. If all traffic channels are busy, mobile unit has to try again and try again. Which, in other ways, if there's a jammed up signal for a given device that's going to make a call, or to a given reception receiving device is the job of the MTSO to also manage call blockings because usually it creates blocks,